Well, good day, ladies and gentlemen. We are on our next to the last Hawks assignment, 8.R.1, which is solving systems of linear equations by graphing. Just a little bit of introduction here. Systems of linear equations sounds a little bit daunting, but all systems of linear equations means is more than one linear equation. So this, two linear equations, constitutes a system of linear equations. Now you know that a linear equation graphs into a line. So three things can happen when I solve two linear equations. That is a system of linear equations. They can intersect in one point, typically what lines do. Hey, they can also be parallel, which means they don't intersect at all. Or thirdly, they can, and this is actually two lines, they can overlap each other. They can coincide and in fact have an infinite number of intersections. So they can have one intersection, they can be parallel and have no intersection, or they can overlap or coincide and have an infinite number of intersections. That's all that can happen when you have two lines in a plane. One intersection, no intersections, or an infinite number of intersections. So we're going to keep this in mind as we look at our systems of linear equations. And remember, this is by graphing. So we are going to be using graph paper on each one of these problems when called for. It says, solve the system of linear equations by graphing. Here's two linear equations. I'm wondering what they look like. And on the Hawks assignment, they say first of all, put it in slope-intercept form. Now, you know that slope-intercept form means y equal mx plus b, where this is my slope, and this is my y-intercept. So we're going to solve each of these equations, or I should say express each of these equations into slope-intercept form. So 6x plus y equal 20. I think I'll move the 6x to the other side and change its sign and get y equal negative 6x plus 20. So I will fill in my first blanks in my first slope-intercept form as y equals negative 6x plus 20. Now here's what's going to happen. You're going to put these two values in, and the Hawks assignment will actually graph these two. First of all, they have a y-intercept of positive 20. Now, as I look at my particular graph paper, I don't think I even have 20. So we're going to do this a little differently. We're going to make each of these guys worth 2. 2, 4, 6, 8, 10, 12, 14, 16, 18, 20. There's my y-intercept. So the y-intercept is the point 0, 20. I graphed it, and it shows up. And by the way, once you put these 2 points into Hawks, it will graph the line for you. You don't have to worry about what I'm doing. But let's find out what this guy looks like. This guy also has a slope of negative 6. Slope, by the way, is, keep this in mind, rise over the run. And that's negative 6. I'm going to put negative 6 over 1. So that means the rise, the up or down movement is negative 6. The run, the left or right, is going to be positive 1. So I'm going to start at my given point and go up or down. This is down 6. So I'm going to go down 6. And this is going to be left to right. It's positive, so I'm going to go right 1. And remember, each of these units is 2. So I'm going to go down 6, 2, 4, 6, and to the right 1, which is right there. So that's going to give me my first graph. And there it is. Keep in mind, though, Hawks will be graphing this for you, so you don't have to worry about anything except filling in your slope and your y-intercept. All right, second point. 9x, 3y equal 24. I need to put it in the form y equals, so I'm going to move this to the other side and change the sign. Divide everything by 3. I'm going to get y is negative 3x plus 8. So negative 3x plus 8. So this line has a y-intercept of 8. 2, 4, 6, 8. So the y-intercept is 0, 8. And the slope is negative 3. Again, that's the rise over the run. I'm going to put negative 3 over 1. So that means 3 down and 1 to the right. So I'm going to start at my point and go 3 down. Remember, each of these units is 2. So 1, 2, 3 down, 1 to the right. There's my second point there. Now, when Hawks graphs this for you, it's going to be very obvious where the point of intersection is. Looks like my point of intersection is right there. Remember, these, each unit is 2, so I got 2, 4, 2, 4, 6. So I got 4, negative 6 appears to be my point of intersection. So I'm going to be asked at the bottom, these two lines, do they have one point of intersection, one solution, no points of intersection, or an infinite number? Hey, they got one point of intersection. So I'm going to choose one point of intersection. And if I choose one point of intersection, I have to tell what it is. It's a 2, 4, 2, 4, 6. It's positive 4, negative 6. And that's all I have to do. So this will graph the two lines. Check your graph, see where the point of intersection is. If there is a point of intersection, there is, and I mark it at the point 4, negative 6. All right. Number 2. Consider the system of linear equations. All right, there they are. Determine if that point lies on both of these lines by using substitution. Now, we have done this before. Remember that every point is an x and a y. So in both of these equations, I'm going to substitute 2 for x, negative 3 for y, and see if I get true statements, get this, in both statements. One is not enough. I have to get true statements in both for this to be the point of intersection. So, first equation. Second equation. And by the way, if you substitute and you get a false answer, you know, like 10 equals 12, something like that, and you realize this point is not on that line, you can go ahead and choose no, because it's got to be on both. This point has to satisfy both linear equations. So everywhere I have an x, I'm going to put a 2. Everywhere I have a y, I'm going to put -3. And I'm wondering, does this equal -12? Let's see. It's 8 plus a -6. Does that equal -12? It absolutely does not. So I've already found out the answer to my question. This point does not lie on both. Why? It doesn't lie on that one. So I'm going to choose no. Nope, doesn't work. Don't even have to check the second point. All right. Similar problem. This one has two applications of it. Here's my system of linear equations. Determine if that point lies on both lines. All right. Let's see. So I think I'll try this one first. This one looks suspicious. So here's my x. Here's my y. 4 for x. Does that equal -5 times my y, which is 3? Yeah, obviously not. So I'm going to pick no for this one, because it doesn't work on this particular line. It's got to work on both. If it doesn't work on this one, it's obviously not going to work on both. All right, here's a second point. Does this point lie on both of these lines? I don't know. Let's find out. So x equals -5. Well, let's try this one first again. So this is my x. This is my y. So 4/5, substituting for x, equal -5 times y. Yeah, no. 4/5 does not equal -20. So once again, I'm going to choose no. All right, so I'm given points. I'm asked if these points satisfy both of these. I have to satisfy both. If it doesn't satisfy either one of them, I choose no. All right, here's another kind of problem. I'm given two linear equations. Hawks has already graphed them for me. And I see that they intersect at the point right there. Let's see, what is this? -1, 1, 2, 3, 4. They intersect at the point -1, -4, apparently. It says find and check the point of intersection. Well, I found it. Let's check and make sure it's not just close to that, but exactly this. So 4 times my x minus my y, does that equal 0? -4 minus a -4 is +4. Does that equal 0? Yes, it does. So it satisfies this one. Let's see if it also satisfies the second one. 2 times my x minus 3 times my y. Question, does that equal +10? I don't know. Let's find out. 2 times -1 minus 3 times -4 is +12. Does that equal 10? Absolutely does. So I'm going to choose yes, and I'm going to put the point -1, -4. Yes, it is the point of intersection. So I looked at my graph, found what appeared to be the point of intersection, checked it in both equations, found out it satisfies both. Yes, that is my point of intersection. All right. Number 5. I'm given two linear equations. X plus y is 55, x minus y is 15. And I'm asked to find the solution, which means the point of intersection. First thing they're going to ask me to do is put it in slope-intercept form. All right, I'll do that. X plus y is 55. X minus y is 15. So you remember slope-intercept form, y equals so many x's plus a number. So I got to solve these guys for y. Move the x to the other side and change its sign. Y equal negative x plus 55. I can do this in one step or two, but I think I'll do it in two. I'll move the x to the other side. The y stays negative. Multiply the entire equation by -1. You could say multiply both sides by -1. You could say divide both sides by -1. You could say change every sign. All of it gives you the same result. Y is x minus 15. So I have two equations, both in slope-intercept form. The first one is y equals negative what? Negative 1x plus 55. Second one, y equals positive 1x minus or plus a negative 15. So I have to introduce a 1 here, since there's no visible coefficient. Negative 1x plus 55, positive 1x minus 15. All right, let's graph these guys. The first one has a y-intercept of 0, 55. Now, obviously, I had to modify my graph in order to find the point 0, 55. So it's 0, 55. And likewise, Hawks has modified their graph too, so that you can plot the point 0, 55. And once again, once you put this in there, the Hawks system will draw the line for you. And this first one has a slope of -1. That's the rise over the run. I got to put something over something that equals -1. Since my units are units of 10, I think I will put -10 over 10. I could have put -1 over 1, but that's going to be hard to graph on this guy. So -10 over 10. So from my 1 point, my y-intercept, I'm going to go down 10 and to the right 10. So down 10 to the right 10. And here's what this particular line looks like. So again, Hawks will draw this line for you, so don't sweat that here. There's my first line. My second line is y equal x plus a -15. My y-intercept is the point 0, -15. So this line goes through the y-axis at -15 right here. 5, 10, 15. Again, my slope is +1. I'm going to say that's 10 over 10, just to give me a good way to graph this guy. This is up or down, so this is up 10. This is left or right. This is right 10. So I'm going to go up 10 and to the right 10. Let's see, here's my y-intercept. Up 10 to the right 10. And again, Hawks will draw these graphs for you. And then they will ask me, is there a point of intersection? Why, yes, there is. It's at the point 10, 20, 30, 35, 5, 10, 15, 20. So it's at the point 35, 20. So I'm going to choose, it's got one solution, one point of intersection, and it is at the point 35, 20. Once again, these last questions, you're looking at which type of relationship do they have. One point of intersection, they're parallel and have no intersection, they overlap and have an infinite number of intersections. This one, obviously, one point of intersection, and there it is. All right, once again, solve by graphing. Here's my system of linear equations. So I'm going to follow my Hawk's directions to first put them in slope-intercept form. Move my x's to the other side and change the sign. There's slope-intercept form. So y equals 3x plus 22. Y equals 3x plus 22. Next one. Solve for y. Move the x's to the other side and change the sign. Divide by 3. And get y equals 3x plus 22. Wait a minute. That sounds familiar. Oh yeah. Oh my goodness. It's the same line. Y equals 3x plus 22. Let's see what that line looks like. It has a y-intercept of 22. I will do each of these as 2 units. So it goes through the point 0, 22. So 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22. So it goes through the point 0, 22. It has a slope of 3. Remember, once you put these in, Hawks will already have graphed your line, so you don't have to do what I'm doing now. But obviously, nothing graphed my line when I put this in there, so I have to do it manually. Slope is 3. I'm going to make that 3 over 1. That means rise, up or down. This is up 3. Run is left to right, right 1. So I'm going to go up 3 and to the right 1. 1, let's see, up 3, 1, 2, 3, to the right 1. Up 3, 1, 2, 3, to the right 1. So that's what my line is going to look like. And once again, this is the line that will be drawn for you by Hawks. Now I have in essence drawn both lines. Here's the line y equals 3x plus 22. Here's the line y equals 3x plus 22. Guess what? These two lines overlap. They coincide, which means they have an infinite number of intersections. So as I'm working this problem and realize, hey, this is the same line. They have an infinite number of intersections. I will choose number 3. And obviously I don't have to put a point in there because they intersect on an infinite number of points. Number 7. Here's a system of linear equations. I'm supposed to find the solution, find the intersection. First, Hawk says, put it in slope-intercept form. All right, here we go. That means solve for y. I'm going to move my x's to the other side and change the sign. I need to solve it for y, not 3y, so I'm going to divide by 3. So y is negative 1x minus 3. First line in slope-intercept form. Y equals negative 1x plus a negative 3. Second guy, same thing. X is to the other side. Same thing, divide by 3. Y equals negative 1x minus 7. Y equals negative 1x plus a negative 7. Now get a look at this guy. Y equals mx plus b. The slope of this line is negative 1. The slope of this line is negative 1. Do you remember this? That lines with the same slope are what? Parallel. So what I'm going to get, since these guys have two different y-intercepts, I'm going to get parallel lines here. But let's see. Y equals mx minus 3. That means the y-intercept is the point 0, negative 3. This y-intercept is the point 0, negative 7. And they both have a slope of negative 1. And a good way to make a fraction that equals negative 1 is, oh, I don't know, negative 1 over 1. So there's my rise over my run. Up or down, that's down 1. Left to right, that's right 1. So this first line has a y-intercept at 0, negative 3. I can use 1 as my unit here, so 1, 2, 3, 0, negative 3. And it has a slope of negative 1, which means I go down 1 and to the right 1. Down 1 to the right 1. Down 1 to the right 1. Down 1 to the right 1. Here's my line. There's a picture of my first line. Let's see what the second one looks like. It has a y-intercept of 0, negative 7. 3, 4, 5, 6, 7. So it goes through that point. It likewise has a slope of negative 1, so I go down 1 to the right 1. Down 1, right 1, down 1, right 1, down 1, right 1. So here's a picture of this line. What the heck? Down 1, right 1, down 1, right 1, down 1, right. Oops, sorry, right there. Okay. So here's a picture of this line. Oh my goodness, parallel lines. And again, once you put this information in the Hawk system, it will draw the lines for you. And you go, hey, how many points of intersection? Obviously, no intersections. So when I choose no intersections, that's because I have parallel lines. All right, we solved the system, which means we found where they intersect. They don't. So my solution is no intersection. One more. Here's my system. Find the intersection or the solution. Again, put them in slope-intercept form. Solve for y. Move the x's to the other side. Divide by 2. Y is 3x minus 14. So my y-intercept, okay, so 3x minus 14. Again, when I put this in, Hawks will draw the line. My y-intercept is the point 0, negative 14. Let's try this guy. X is to the other side. Y equal 3x plus 19. Already finished. 3x plus 19. There's my y-intercept, 0, 19. And it likewise, hey, look at this. They both have a slope of 3. I know that lines that have the same slope are going to be parallel. They have different y-intercepts. So these guys are going to be parallel lines again with no solution. But again, let's draw it. 0, negative 14. And the other one has a slope, a y-intercept of positive 19. Barely made it. And they both have a slope of positive 3. And I'm going to make it a fraction, a rise over run. So rise is up or down. This is obviously up 3. Run is to the left or right. This is positive, so it's the right 1. So I'm going to go up 3, right 1. Up 3, right 1. Up 3, right 1. Up 3, right 1. Here's this feller. And this guy's going to be parallel to it, but through the point 19, so it's going to look like this. Now again, Hawks will draw these for you. So all you have to do is fill in the slope and the y-intercept, and it'll draw the lines. As you look at them, do they have one solution, one intersection, no intersections, or an infinite number? They're parallel. They have no intersection, no solution. So that's what I choose. All right, that's the 8 problems from 8.R.1, and I will get to the other one where we're going to use substitution to solve systems of linear equations a little bit later.